we're still doing probabilities, but we are now getting into some nicer ones where it's a little less thought on our part. We don't have to try to decide is this an and or an or, an independent, dependent, all the stuff. We're looking specifically at binomial distributions. And binomial means, do I need to? Okay. I'm gonna watch my video for that other handout that we did. Not that I helped you to. If you see a janitor, you might know I need them all. Okay. Binomial is when there's only two possible answers, success or failure. P is the probability of success. We have a set number of tries. And so then we had this whole formula for how we can calculate it. So it was, remember this,
X squared
this n choose x, p to the x power 1 minus p to the n minus x power. And we did have on our formula sheets a table that we can use sometimes, but remember it only had certain probabilities and certain n values. So in those cases we can use the table, if not we have to calculate it. So in this one, 65% of adult Americans are in favor of the death penalty for individuals convicted of murder. In a random sample of 15 adult Americans, we're going to find each of these probabilities. What is my n?
10.
15 for this whole thing. I haven't read part A yet. P. Okay, P is probability of success. In this case, it would be that they are in favor of it. So what is that?
65.
Okay, this is binomial. We have a set number of tries, 15 Americans. Everybody has the same probability of being in favor of it. These are all independent. So the probability that exactly 10. So I'm finding the probability of 10 exactly. This is one that we could use the table for. So if you look, I think it's the back page when n is 15.
Yes.
Then you go down to x is 10. Bless you. And my p across the top is 0.65. Did everybody find that number? All right. B, no more than 6. If it's no more than 6, what could x equal?
5. 0 1 equal 5. Is that 0.6?
Can it equal 6? If it's no more than 6,
Yes.
so would you guys agree with that? No more than 6 would include 6. So we have to add all of those up on our table. So I'm going to the 0.65 column. And I'm going to add up. So you notice the first couple for 0 has 0.4 zeros and a plus sign. That means it's a positive number, but the first 4 digits are all zeros. So we really just don't add that in until we get to x equals 2. Alright, and what do we get?
0.043.
Is that alright with everyone? And then I went to look at a couple, I think you might have had a more question that asked you to graph the binomial distribution so I wanted to touch on one of those. So graph a binomial probability distribution with n equals 8 and p equal to 0.15. So that is just creating the graph with the probability on the y-axis, and our x-axis is our different values up through 8. So 0. So we could calculate every one of these probabilities by hand, but we can also look at our table to get them. I think when n equals 8 is one that's on here. P equals 0.15. So we're just approximating each of these. So my y-axis count by 0.05. So at 0, my probability is 0.2725. One is 0.3847, so not quite. Two is 0.24-ish. 3.08. 4.0185. 5.002. 6.0002, and the rest are just like zeros, they're so small. The only point of this is if I want you to describe the shape. Can you tell me what the shape of that is? Because here's my peak, and I have more points extending onto the right.
Is there a reason why 0 is usually lower than the second number? Why? Or like, just like with the graphs that we have graphed, it's always been like 0 and then 1.
It has to do with the mean,
Okay.
but yeah, it's just matters with the probability, the p-value really. Are we okay with those?
I don't know where you get them.
The numbers, I just read them on my because my n was 8 here, I think it was 15.
Oh, eight. I'm sorry.
No problem. Let's throw in, instead of B, I want to do an example since it's Monday, and it was a few days ago when we did this. If I said, find the probability if n equals 9, p equals 0.07, and x is 4. Is this one I can use the table from?
No.
No. So let's refresh how we use the formula for that when you can't use the table. So it's in choose x p 0.07 to the x power, so that would be 4. 1 minus p, so 1 minus 0.07. 0.93 to the n minus x, so 9 minus 4 is 5. In other words, it's saying we had 4 yeses and 5 no's here. So remember to plug this in. You start your parentheses, you type in your 9, and then if you went math over to probability, you wanted the NCR. 0.0021. So that's what we do if we can't read it from the table, and we have to calculate by hand. Alright. Is that one okay? Alright, final thing. This isn't super important right now, but it will be in the next unit. In general, when n times p times 1 minus p is bigger than 10, the shape of the distribution turns out to be more bell-shaped. Did I not print those slides for you?
Yeah, you did, yeah,
So I did
it's
tell.
fine. You know,
Oh.
Sorry, I was probably trying to consolidate slides
It
and
is,
save
okay.
another piece of paper. So,
yes,
and we can also use the empirical rule to decide if something is unusual. Remember, empirical rule said 95% of our data should fall within 2 standard deviations. So if it's more than 2 standard deviations, the probability becomes very unlikely. The other way to decide if something's unusual is anytime the probability is less than what?
5%.
5% is considered unusual. So final example. According to Experian Automotive, 35% of all car-owning households have 3 or more cars. The researcher believes this percentage is higher than the percentage reported by Experian. He conducts a simple random sample of 400 car-owning households and found that 162 had 3 or more cars. Is this unusual? So a couple different ways we could do it. We can find the probability of this. We could also do it in terms of standard deviations. Which way do you guys want to go with it?
Which one's the NCR?
Hmm.
Can we do the NCR one here?
Yeah, that's so you want to do the formula? So n choose x, p to the x. Okay, what's my n?
400.
What's my p?
0.35.
Okay, and what's my x?
160.
400, choose 162. 35 for 162. 1 minus that. N minus x, 400 minus 162. Alright, let's try typing that in.
Overflow. I've never gotten that error
Yeah.
before. That means
So what happened to our calculator?
error.
We broke the calculator. The numbers are too big. It can't calculate it. So, we're stuck trying to do this yet using standard deviations because our calculator couldn't. It was too many digits.
What a baby.
I know. Isn't that ridiculous? So, let's find mean and standard deviation. This is a good review for Monday as well. Remember, if you look back in your notes, the mean for a binomial distribution is just n times p. So 0.35 times 400 gives us a mean of what?
140.
Standard deviation is the square root of n times p times 1 minus p. So 400 0.35 0.65. So if we think about this, 140 is the mean. We said if it's bigger than 2 standard deviations away, then it would be unusual, right? So if I do my mean plus two standard deviations. So 140 plus my 9.5394 times 2. That is so remember, we expect 95% of our data to fall in there. I didn't find my lower limit, but I certainly could. If I did 140 minus my standard deviation times 2. So 95% of my points should fall between 120 and 159. What was the value we were looking at?
162.
162. 162 is going to be out here. So is that going to be likely?
No, it's gonna be in
No, there's a 95% chance it's below that value. So this would be unusual. Anything that fell in those two standard deviations would not be unusual. So again, only reason we had to do it this way was because our sample was so much bigger, our calculator couldn't calculate that much. Questions for me?
Miss Dyer's phone just rang.
So we have to turn in that 6.1 still. I'll probably about just at the end of class we grade that one. That way you guys have more time to work right now and just ask questions.
That's the one from many days ago. correct?
Yeah, like last Thursday.
That's not the one we're doing.
I just didn't collect it Friday. So these were the problems from Friday. You have time to work